Hello and welcome to Mr. Adelman's fun-filled math class, more specifically geometry class. Last session we talked about conjecture, patterns in conjecture, and geometric conjecture. Today is the follow-up to that when we will talk about counterexamples. When we are dealing with conjectures, we know that sometimes conjectures are true and sometimes they're false. If you have a conjecture that is true most of the time but false at least once, then that conjecture we say is actually false. In order to prove that a conjecture is always false, see how this fancy marker works, always false, then you need to have what's called a counterexample, and you only need one counterexample to prove that a conjecture is false. I'm going to give you an example of this. Let me bring this down in case you do not finish copying. The example that we're going to use today is that x squared equals 9. So a very reasonable conjecture that we can make is that if x squared equals 9, then x would be 3. And in most cases this is going to be true. However, we can come up with a counterexample. Now we know that if x squared equals 3, then we plug in the 3 for the x we squared, and it does in fact equal 9. But a counterexample would be if there was some other number that we could plug in for the x and come up with 9. And the answer would be, of course, if x equaled -3. Then that means that -3 squared also equals 9. So because x equals -3 is not the same as our conjecture, that would make this conjecture false. And we only needed one counterexample, and that's all we were given, this one counterexample, to make that false. So what you would need to do is to come up with some other conjecture. One conjecture that you could have, a true conjecture, would be something like x equals the absolute value of 3. That's actually not true. We could say that the absolute value of x would equal 3. That would be a reasonable conjecture. And that sums up counterexample. There's not much else you need to know about that. Finding the counterexample is actually easier than coming up with a conjecture, in my opinion. Hopefully you will feel the same. At this point I am supposed to give some sign off, but I can't think of anything, so I will steal someone else's each time. So I will say Seacrest out. Goodbye.